Welcome to sitza.com. Oxidation of aldehydes and the ketones. Both aldehydes and the ketones contain a carbonyl group, and both the compounds we can oxidize them further into carboxylic acids. Aldehydes are easy to oxidize than the ketones because aldehydes contain this C carbon hydrogen bond. So this bond you can easily convert into the OH because the carbon hydrogen bond strength is not so strong as we have a carbon carbon bond strength. So carbon carbon bond is very stronger than the carbon hydrogen. That's why aldehydes can be easily oxidized than the ketones. When you oxidize the these aldehydes, you get a carboxylic acid, and from ketones also we can get carboxylic acids. Both can be converted into the carboxylic acids using different types of oxidizing agents. But as I said, aldehydes can be easily oxidized, right, than the ketones. Ketones are difficult to oxidize as compared to the aldehydes. So therefore you can oxidize the aldehydes by the weak oxidizing agents as well as the strong oxidizing agents. But ketones, you cannot oxidize the ketones by weak oxidizing agents. You need pretty strong oxidizing agents, and that too under the drastic conditions. Only then you can convert the ketones into the carboxylic acids. So the different types of oxidizing agents that we normally use are like you can say the KMNO4, right? This is KMNO4 in the alkaline medium. We can use it as the oxidizing agent, and we can use also the potassium dichromate K2Cr2O7 in the acidic medium. We use this one as an oxidizing agent, but both the compounds actually are very strong oxidizing agents, right? These are very strong oxidizing agents. Even you can use the nitric acid HNO3 also, which is a very strong oxidizing agent, right? So you can use the nitric acid HNO3 also as a strong oxidizing agent. You can use these strong oxidizing agents for the oxidation of aldehydes and the ketones both, right? So strong oxidizing agents can convert aldehydes and the ketones into carboxylic acids. However, oxidizing agents like you can say the Tollene's reagent, right? We have a Tollene's reagent. Tollene's reagent is a weak oxidizing agent, okay? And similarly, we have a Fehling solution, right? We have a Fehling solution. We can use this one as an oxidizing agent. We have a Fehling C and the B. We mix them, and then we use this one as oxidizing agent. But both are actually weak oxidizing agents, and the weak oxidizing agents can only oxidize the aldehydes, not the ketones. Correct? Weak oxidizing agents can only oxidize the aldehydes, not the ketones. But strong oxidizing agents can oxidize both aldehydes and the ketones. So these different types of oxidizing agents we often use to identify a particular compound, whether it is an aldehyde or a ketone. For example, if you have a compound, you have a carbonyl compound A, right? It is a carbonyl compound A. We don't know what it is. Is it an aldehyde or a ketone? We don't know. Now suppose if you use here you use a Tollene's reagent, right? You use a Tollene's reagent, and what we find this Tollene's reagent can oxidize this compound A into the carboxylic acid, right? So you get here from this compound you get a carboxylic acid. But the question is what it is. Is it an aldehyde or a ketone? As we know that weak oxidizing agents can only oxidize the aldehydes, right? They can only oxidize the aldehydes, not the carboxy, these ketones. So that means this compound A, a carbonyl group, a compound containing the carbonyl group, is not an ketone, it's an aldehyde, because Tollene's reagent is a weak oxidizing agent. It can only oxidize the aldehydes. So that means this one is an aldehyde, right? This is an aldehyde. That's why it can oxidize the this compound A into the carboxylic acid. Now, as we discussed that if you have aldehyde, it will convert it into the carboxylic acids, and if you have a ketone, now in the ketones you have two alkyl groups. Either the you can say the this bond breaking will take place from this side, and you will get what? You will get these two compounds, or the bond breaking can take place from here, and you get. So that means when you have a ketone, you get different types of compounds, right? And certain compounds are major products, and some of the compounds are the minor products, right? So we will discuss this in next video. What are the products that you will get if you take a particular ketone and you will oxidize it, right? Right now you simply remember that if you take an oxidize, if you take a strong oxidizing agent, you can convert this ketone into the carboxylic acids only when you take a strong oxidizing agent, right? Only a strong oxidizing agent like potassium dichromate under the drastic conditions, or you can see the KMNO4, right? Or nitric acid. Only strong oxidizing agents can convert the ketones into carboxylic acids, and aldehydes can be converted into carboxylic acids both by strong oxidizing agents and also by the weak oxidizing agents, right? So you can use any one of them, weak or strong, but the weak will not work here in case of ketones, right? So let's take a few more examples here. Now with the tolerance reagent, as we learned, the tolerance reagent is a weak oxidizing agent, but the question is, what is a tolerance reagent? What actually it contains, right? Basically this tolerance reagent, this is an ammoniacal solution of a silver nitrate. Correct? This is an ammoniacal solution of a silver nitrate, and it is prepared by mixing the ammonium hydroxide solution to the silver nitrate. So you get this compound, right? You get this compound. Okay, so tolerance reagent contains this, this ammonia, this silver complex, right? And when you take this tolerance reagent, what you get, it will convert the aldehyde into the carboxylic acid, COH, and you will also get the metallic silver. See, you will get a silver. So silver, this is a solid, and if you take a compound, you don't know what it is it an aldehyde or a ketone? Suppose you take in the test tube, and to this compound, when you add some tolerance reagent to it, right? Tolerance reagent to it. So what you will get, if it's an aldehyde, you will get a carboxylic acid. But how would you know, whether the reaction does occur or not, right? You will get a precipitation of a silver, right? You will get a solid precipitation of the silver on the sides of this test tube. So you will get a metallic silver. So this test tube will behave like a pin mirror now, right? It will behave like a mirror. So that's why we often call this one as a silver mirror test, right? We call it as a silver mirror test. Why? Because it gives us mirror like shape, mirror like situation for the test tube. Your test tube behaves like a mirror because silver is prepared when you oxidize the aldehyde into the carboxylic acid, and only aldehydes can be oxidized. Now this is very important. Both aliphatic or aromatic can be oxidized. Whether if it is a benzaldehyde, right? You have a benzene here, right? Attach it with the COH. Okay. Both aliphatic aldehydes as well as aromatic aldehydes can be oxidized by the tolerance reagent, right? Fehling solution. What is a Fehling solution? Fehling solution is actually, this is an alkaline solution of a copper sulfate, correct? Which contains, some sodium potassium tartrate also, right? So basically, the Fehling solution is a mixture, right? Mixture of a sodium potassium tartrate and a copper sulfate solution. And the basic element that we need here in this oxidation, process is this copper, right? This is the copper. So this copper actually oxidizes aldehyde into the carboxylic acid, and copper is converted into the brown red precipitation of copper oxide. Okay, this is the cuprous oxide, Cu2O, and you get a red precipitation at the bottom, right? Red precipitation at the bottom. That means, again, if you have an unknown compound and if you take it this compound into the test tube, and then you will add some Fehling solution in it, right? Fehling solution in it. So if you get a brown red precipitation at the bottom, it means that the compound is aldehyde, because Fehling solution can only oxidize the aldehydes, not the ketones. And one more point, Fehling solution can only oxidize the aliphatic, right? It can only oxidize the aliphatic aldehyde, but not the aromatic aldehyde, right? Not the aromatic aldehyde. So if it cannot oxidize the aromatic aldehyde, that means what? You can use this Fehling solution to differentiate between the aldehydes, whether it is aromatic or is it a aliphatic aldehyde. So Fehling solution can oxidize only aliphatic aldehydes, not the aromatic aldehydes. That means you can differentiate between the aliphatic and the aromatic using the Fehling solution. And tolerance reagent can oxidize both aliphatic and aromatic. So tolerance reagent we cannot use to distinguish between the two aldehydes, whether these are aliphatic or aromatic aldehydes. Tolerance reagent is going to oxidize both of them. Fehling solution can oxidize only the aliphatic, not the aromatic. So Fehling solution, we can, it can further distinguishes between the aldehydes. Is it aromatic or an aliphatic? So let's take here a couple of examples, right? Suppose we have a compound A, a carbonyl, a compound that contains a CO group, right? Whether it is aldehyde or not, we don't know. Now what I do, if I take here the KMnO4 solution and it can oxidize it into the carboxylic acid, right? Carboxylic acid, you get a carboxylic acid. And same compound, when you react with the tolerance reagent can oxidize it, right? So you again get a carboxylic acid with the tolerance reagent, but you do not get anything with the Fehling solution. But when you react to the same compound with the Fehling solution, there is no reaction. Means the Fehling solution does not oxidize this carbonyl compound, but only the tolerance reagent and the KMnO4 can oxidize. So what is this compound A? Is it aldehyde or a ketone? That is the question. Since we know that this tolerance reagent can oxidize aldehydes, only aldehydes, right? So that means this compound should be aldehyde. See, KMnO4 cannot tell us because the strong oxidizing agent can oxidize both, whether it is a ketone or an aldehyde. So we cannot distinguish from here. Only the tolerance reagent will tell us whether it is aldehyde or a ketone. Since it oxidizes it into the aldehyde, into the carboxylic acid, that means the compound is aldehyde, right? So the first point is this is aldehyde. But whether it is aromatic or aliphatic, what type of aldehyde it is, we know that Fehling solution can oxidize only aliphatic, not the aromatic, right? Fehling solution cannot oxidize the aromatic. So that means this compound is an aromatic. This compound is an aromatic aldehyde. Why? Because it doesn't react with the Fehling solution, and Fehling solution does not react with the aromatic aldehyde. So that means this is an aromatic aldehyde. Got it? This is how we use these reagents to identify what type of a compound it is, what type of a carbonyl group the molecule contains. Hope you got the concept. Thanks for watching the video. Bye for now.